Hi everybody, welcome to LCC 150D. This session is about Chapter 2, and we're going to deal with how we describe distributions with numbers. And basically we'll be looking at the center of the data, the mean, median, and then the variation, how far the numbers vary from each other. Again, right now we're learning how to present data. We haven't learned how to get the data. And once you learn how to present the data and get the data, then you make decisions. So you have to start thinking about what are you going to do with these numbers. But today we're going to focus on how do we get these numbers. Now we're going to do it by using Excel. So I've created an Excel chart here. And an Excel chart is going to be these numbers that you can find on page 44 and 45 of your text. It's example 2.4. And 2.4 is on page, again, 44 and 45. These are the numbers. You can see the numbers right here for this distribution. So I've put them in a column. Okay, let's go back to the PowerPoint here. And we're going to look at the mean. And here's this long equation you've probably seen in the book. All of you know, you've probably learned this back in the 4th grade. You add up all the values, divide by the number of the values. That's not a big deal. The median is very important. In fact, it's usually used more than the mean because just a few numbers that can skew the data can change the mean. And you can also have an incorrect number as well. So the median is the better number because it's ordered values. You see the word ordered over here. And the ordered values are half above, half below, and it tells you what to do with odds and evens. And this is the equation to find the median for a sample size of n, and it gives you an example. Okay, so that's great. And you have to know the difference between mean and median. So make sure you know that, and you can look at this question as well at some particular time. But first, next I'm going to go to the Microsoft Excel, and here are my numbers from example 2.4. I'm going to find the mean first, M-E-A-N, the mean. Alright, now that is average in Excel. It's called average. Now the way to get a formula in Excel is you write or you print or you put in the equal sign. I'll go back. Notice how this changes when you put the equal sign. Put an equal sign, now you have these things. This is a function and you have a new function. It's called a function bar. And right here we have different functions. And these are the functions that I have used in the past. And you can see I've practiced, which is a good thing to do, by using some of these functions that we're going to talk about today. But in case you can't find them, there's something called more functions. And in here, you can select a category because look at all the functions you can go through and spend a lot of time. So we're going to get a subset of that, and it's statistical. So now we have statistical. So it's made the set of formulas a little bit shorter. So we're going to look at average because that's what mean is in Excel. Alright, so we're going to find the average. Then it asks you what are the numbers that you're going to take the average of. So instead of using that equation you saw in the book, all you have to do is click on this little icon here, and now it's waiting. See, look how it changed, and the arguments are the numbers. So then you click and you drag the numbers that you want to take the average of. And then you click this icon again. And you're all done because that's just the first series of numbers. Press OK. There's the average, 22.4667. Now, up here you can make this number smaller or bigger. See where it says number? And you can make it rounded off. So usually you put it to the nearest tenth unless it's asked differently. And just for clarification, I'm going to write the mean equals. In fact, just to be fancy, I can make this column, everything go to the right-hand side, and then I'll make everything go to the left-hand side on here. So it looks like that. Alright, so now we have a number that says mean equals. So it's 22.5. The mean of the average is 22.5. Now we're going to find the median. So I press an equal sign again. Watch how this changes. Let's go back to statistics. It's already statistical. Now we're going to find the median. And so it's all in alphabetical order. There's the median. Okay. There's the symbol again. Now it's asking you. It says, do you want to take the number D9 to D10? That wouldn't make sense because if you look, D9 to D10 doesn't give us anything. So D9 to D10 doesn't do anything. So we'll click on this icon again. Now it's waiting for the numbers that we want to find the median. And those are the numbers. We've got them all highlighted. Click on. That's all you need, A1 to A15. So we press OK, and there it is, 20. So just for clarification, we write in the word median equals. That way, when you send this to me, it will make sense. So now we have a median of 20 of these numbers and an average or a mean of 22.5. So that's how that's found. Okay. Now the next thing, go back to the PowerPoint here, and there are different. Now it's spread of variability. Spread is how far these numbers are apart. If you collect a bunch of data and all the numbers are all over the place, it really doesn't mean anything. If I give an exam and the average grade is 85, but the grades range from 5 or 0 to 100, it's probably not a good measure of the class. But if I have an average of 85 and the numbers are between 80 and 90, then that's a much better indication of how close the numbers are. So variability is very important to help you make decisions. Remember the title of the course. So one of the things that we do is quartiles, and this is explained more specifically in the book. You order your numbers and the data. You order the data in order, and you find the first quartile, which is 25%. The median is actually the second quartile and the third quartile. So here are some other things that you can glance through, and they have an example here. Now, using quartiles, we have this 5-number summary. Very important because it's going to give us our stem and leaf, or box plots, sometimes called stem and leaf, but box plots. So for these numbers, this is what we get. So here's the box plot, and that's what it looks like. So now we're going to use Excel to see what we can find. So we're going to go back to Excel, and now we're going to find the quartiles. All right. So again, I go in here and I put an equal sign. We're going to find the first quartile. Okay, so we have up here statistical. Let's look at quartile. So in alphabetical order again, is quartile. Press OK. Now it's asking for the numbers. All right, so again, click on that icon and select your data. Click it back on, not the X, because that will shut it down. And now it's asking for what quartile. If you're not sure, can do that, but here it is. Quartile is a number between 0, first quartile, median, third, fourth. We already have the second quartile, which is the median. We want the first, so we enter the number 1 there. And this gives us our first quartile. So first quartile, and looks like that. It's 10. Okay, let's find the third quartile. So now we're going to go in here, put an equal sign. Do the same thing. Quartile is already over here, so we can just press. We don't have to search it. Here's the array. We're going to find a third quartile of our same set of data, and this time we put in a 3 equals. So the third quartile is 30. Now, for the stem and leaf, the box plot. If we go back to our box plot, this is the information that we need. We need a minimum, quartile, median, quartile, maximum. So let's find the minimum and the maximum of these numbers. Now it's very easy with this set of numbers, but I'll show you that we can find the minimum using these functions again. Let's go to statistics. We are finding minimum, so let's find the minimum. There it is. Minimum. What is our data? Our data is here, are here. Data is plural. Don't lose points for putting singular. And so the minimum number is 5. Let's find the maximum. Same thing. Statistics, more functions, max. Right there. What are the numbers? A1 to A15. Back, and just for clarification, it's always good to put clarification, maximum is 60. So you can make a box plot with this information, because if you go back to, this is what you need for a 5-number summary. You'll be asked this on one of the assessments to give me the 5-number summary of a set of data. So be ready to do that, and you can use Excel to do that. So once you have this, now you can find the information for the stem and leaf at box plot, same thing. So now I've found a site that I can send to you, and it's up here, and I'll send that to you as well. And it's on it's basically a box plot simulation, and it gives you an example. But what's kind of neat is that you can make your own box plots. So I'm going to show you how you can do this. I'm going to get rid of all of these numbers. Actually, you can just clear all. Okay, there's nothing there. Let's go back to our Excel chart, and let's highlight, copy these numbers. Actually, I can just do it there. Copy these numbers, and I'm going to paste it in here, and I'm going to draw the box plot, and there's the box plot. So now you've got a box plot, because we don't have that. Well, we can spend hours using Excel to draw a box plot, but we're not going to do that. So we're going to just use a box plot simulation that you can find online, and there it is. Everything is over here, and it shows labels. If you don't like the labels, it just looks like that, but it's much more convenient and easier to see for us. Now, if you're going to send this to me, this is what you can do. On your computer, there's an Alt Print Screen button. Of course, the Alt is on the lower left-hand side. Print Screen is on your keyboard way in the upper right-hand side. If you can't, maybe do Help, but it says Print Screen. So I'm going to press, you can't see me do it, but Alt Print Screen. I've just copied this screen. I'm going to open a Word document, and I'm going to paste this screen. Now it's pasted. And you can make this bigger so we can see it and enjoy it. And so when you have to send it to me, you can say, here it is. You've used a online simulation for it, and you can also just copy and keep it for your records. But this is the way to do it for my purposes as well. So now you have a box plot of the data that we have over here. Okay? The next area that we have to look at is variance. Now, variance and standard deviation. And here's the definition of deviations and variance and so on. It can be quite complicated, but the deviation is important because it tells you how far apart your data is. Again, if I gave a grade, if I had a test and the grade was 85, and the standard deviation was like 10, 12, 15, that meant the grades are all over the place. But if I had a standard deviation of around 1 or 2, then I know that my numbers are closer, and that average or that mean really is important. It tells me something. When you have a wide deviation, it doesn't tell you anything. So you want really good data, and variance is a good way of measuring that data. Now here's the variance formula. Looks fun, doesn't it? S squared equals 1 over all blah, 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 blah. Okay, standard deviation looks like this, and that's going to be pretty complicated too. You don't have to do all this, because if I'm going to ask you for standard deviation on a test, and if you're going to spend all this time doing it, you're wasting your time. I want you to be able to understand what these numbers mean. So it's the final answer that's important. How do you get the final answer? Well, you go back to Excel, and now let's find another spot here. We're going to put in an equal sign. And we're going to go back in statistics and find the standard deviation. So the standard deviation is down here. Watch out, the standard deviation A, standardized STDEV is the standard deviation. That's what we want. So press OK. Again, looking for the data. What numbers are you going to use? Those are the numbers. We've got them all highlighted. So that's clicking on OK. And there's our standard deviation. So I'm going to write that down. And just widen this up so it makes more sense. And again, you can also make this number smaller, so it looks like that. So out of these numbers, the standard deviation, out of all of these equations that you can use, of this equation, you get this answer, 11.6, through Excel. That will make life much easier for you. All right? Hopefully this will help. If you do not help, then ask questions. I will send you the site for this box plot simulation. It's very convenient, and have a good day.